Hi, this is the third and last presentation addressing the basics of hardware-software co-design. And again, we will follow Patrick Chaumont's book. In this case, I expect that you will be able to explain the concepts of concurrency and parallelism in hardware-software co-design. To start with, we should be able to clarify the difference between concurrency and parallelism. Concurrency comes from operations independency, which enables them to be carried out simultaneously. But concurrency does not imply parallelism, since what we call simultaneously may be achieved by multiplexing two independent processes in the same hardware platform. We will come back to this possibility in the following slide. On the other hand, when we consider parallelism, simultaneous execution requires duplication of hardware resources. The dot product application at the end of the previous presentation offered an example of parallelism, since the digital signal processor that was considered comprises two multiply accumulate units. I think that these three statements will help you to realize the difference between these two concepts. Parallelism in terms of hardware is kind of intuitive when we look at a schematic diagram. But when we think about software, we realize that an application can be executed sequentially, concurrently, or in parallel. If we have a single CPU, the code may execute sequentially, but we can multiplex the execution of code segments for different processes if these processes are independent. Multiplexing their execution in time appears as simultaneous execution to the user. On the other hand, multiple CPUs means that real parallelism is possible, but the software may need to be modified to take advantage of this possibility. The problem of adding an array of 8 numbers offers an interesting example, and I would like you to study it in detail. Notice that a software solution running in a single CPU would only be able to carry out one addition at a time, so we would need to carry out all 7 additions one after the other. 1 plus 2, then plus 3, plus 4, etc. However, these 7 additions can be carried out in only 3 stages if we explore the intrinsic parallelism of this application. Since we could carry out 4 additions in parallel in the first stage, as shown in this slide, followed by 2 additions in parallel. So I would like to ask you to use the Zero board to try out this example, first in software, then in hardware, and to compare the two cases in terms of design effort and quality of results. I did it myself for the hardware implementation using a process to ensure a proper sequence and concurrent addition statements within each state to ensure parallel operation when possible. This slide shows the resulting logic structure, and this one shows how the addition process unfolds in the 3 stages. Please take a moment to make sure that you understand the waveforms. Why is it that the results of the first 4 additions become available only at the second rising edge of the clock? To finish this sequence of presentations, I would like you to pause here for a moment and to consider these 3 tasks. And that's all. Thanks for your attention.